When an environmental spill occurs, the first 48 hours are a race against time. Every decision in those 2 days can make the difference between protecting ecosystems or facing years of damage.
We treat these moments like a paramedic arriving at an accident scene. Fast, precise, and determined to save as much as possible.
A recent produced water spill in a sensitive drainage area of North Dakota shows how critical this approach is.
One rainy morning, a pipeline rupture released less than 500 barrels of produced water onto a well pad. Heavy rainfall quickly overwhelmed berms and pushed the contaminated water downstream. Fortunately, modern pipeline monitoring systems equipped with fiber optics and acoustic sensors detected abnormal pressure and flow almost instantly.
These technologies can pick up even subtle changes, alerting operators to potential leaks before there is any visible evidence.
Within hours, our operations control center dispatched field personnel to verify the leak, shut down the affected pipeline, and assess how far the contamination might travel. Early detection and quick isolation of the source are the first, non-negotiable steps. Once the flow is stopped, the real challenge begins: keeping contaminants from spreading into rivers, wetlands, or groundwater. Once the source is secured, we mobilize a cross-functional response team. Environmental scientists, field technicians, and emergency crews converge on site, each with a clear role. They work from the same set of data: spill location, estimated volume, and environmental conditions, so every action is coordinated. The immediate priority is containment. In the North Dakota spill, responders quickly realized that diluted produced water had already traveled nearly a mile down a drainage channel. Emergency crews built sandbag and earthen berms to trap the flow, working in pouring rain and mud. At the same time, they installed a high-watt-density polyethylene (HDPE) recovery pipeline to pump contaminated water back to a secure location. Floating booms, physical barriers that sit on the water's surface, were deployed at key points, including near the drainage's confluence with a large lake downstream. We combined absorbent booms, which soak up oil and hydrocarbons, with non-absorbent booms that block debris. These layers of defense create time and space for other teams to act. Every move is driven by science. Field technicians use handheld YSI multicometers to measure water conductivity, pH, dissolved oxygen, and temperature. Quick chloride tests show how far contaminants have spread, helping crews decide where to place barriers and pumps. Produced water isn't just salty, it can carry hydrocarbons, heavy metals like barium and strontium, and naturally occurring radioactive materials. Knowing exactly what's in the water shapes how we respond. While containment crews hold the line, environmental scientists begin a different but equally urgent mission: mapping exactly where the spill has gone. This step is called delineation, and it's a mix of science and detective work. Teams wade through drainage channels and wetlands, collecting water and sediment samples as they go. Each point is logged with precise GPS coordinates. These samples tell us how far contaminants have spread, which areas are at risk, and where to focus intensive recovery. To speed up the process, we also deploy drones equipped with advanced cameras, scanning the landscape from above. Remote sensing allows us to see the bigger picture, spotting slicks or discoloration in areas that might be hard to reach on foot. Every sample and aerial image adds a piece to the puzzle. Maintaining a strict chain of custody is critical. Every bottle of water and soil sample must be carefully labeled and tracked from field to certified lab. This isn't just about regulatory compliance. Accurate data is the foundation for every decision we make next. If we misjudge the footprint, we risk leaving contaminants behind or wasting precious time and resources. In North Dakota, this rapid delineation revealed the produced water had reached a beaver dam nearly a mile downstream. Because we knew the exact boundary, we could build additional berms and deploy more booms in the right spots, preventing any further spread. Once the affected area is contained and mapped, the focus shifts to recovery. This is where long hours and heavy equipment come into play. The objective is simple: remove as much contaminated water and soil as possible before it can cause further harm. In the North Dakota spill, crews worked around the clock, pumping out more than 18,800 barrels of impacted water within the first 48 hours. Giant frac tanks and chemical totes lined the well pad, filling steadily as water was removed from the drainage. Once full, the contents were transported to deep saltwater injection wells, geological formations far below drinking water sources, where disposal is permanent and highly regulated. To ensure nothing escaped downstream, a lined surface water containment dam was built at the drainage's lower end. Sampling stations were set up on the down gradient side of the dam, testing water quality continuously. Results confirmed no exceedance of state or federal standards, a clear sign that containment and recovery were working. Pumps run non-stop, crews rotate shifts in harsh weather, and logistics teams manage a constant flow of contaminated materials leaving the site. Real-time data from field sensors guides every move, directing teams to the highest concentrations of contaminants first. Every gallon recovered is one less threat to wetlands, lakes, or aquifers. By the end of the first 48 hours, the North Dakota response had minimized vegetation loss, kept contamination out of the nearby lake, and laid the foundation for long-term restoration. Environmental spills are daunting. They happen fast, often in the worst possible conditions, and the stakes couldn't be higher, but they do not have to become ecological disasters. When teams move quickly, act decisively, and stay relentlessly focused, it's possible to protect even the most vulnerable ecosystems. At Genus, we thrive in this pressure cooker environment. Our advanced monitoring systems catch problems early. Our field crews know how to contain and control contamination before it spreads, and our scientists provide the data that drives every strategic move. It's a seamless combination of technology, expertise, and sheer determination. The North Dakota response proved what is possible when everything comes together. In just 2 days, we not only stopped the source and captured thousands of barrels of impacted water, but we also prevented long-term damage to wetlands, wildlife, and a nearby lake that many communities depend on. This is why we treat the first 48 hours with absolute urgency. Every berm, boom, and pump is a calculated move to save what matters most. Every sample collected is a promise that we will understand the full picture and do what it takes to restore it. When the alarm sounds, we are ready. Ready to act with speed, ready to bring science into the field, ready to protect ecosystems and the communities connected to them. Because in the face of crisis, there is no second chance to get it right. If you found this story inspiring or learned something new, make sure to subscribe to our channel so you don't miss our next response in action. Leave a comment to tell us what you think or ask your questions. We read them all. And please, share this video with friends or colleagues. Together, we can raise awareness and protect the places we all depend on.